Have you ever been to a beach? If yes, then sand is probably something you would have enjoyed playing with. If you look at sand closely, you can see several particles apart from sand like tiny shells, pebbles, small plants and animals. Basically, it looks non-uniform. But when you look at it from a distance, it appears all smooth and uniform, as if it is a single substance. This can seem confusing. As sand is made up of different particles, it is definitely a mixture. But are the different particles distributed uniformly or not? Before we try to answer this question, let us study a few other mixtures. From that, let us add a drop of food color to water in a glass and stir it. Can you distinguish individual particles of food color? Or can you distinctly point out water from the food color particles? Seems like we cannot. So this mixture has a uniform distribution of food color in water. Now let's take another glass with the same quantity of water. This time we add talcum powder to it. Oh, the particles deposit at the bottom of the glass this time. That is, this sample has physically distinct parts. You can easily see two layers, one of talcum powder and the other of water. Both our samples are mixtures, but they are very different from one another. At this point, we can easily conclude that this mixture has a uniform distribution of particles and therefore a uniform composition, whereas this one has a non-uniform distribution of particles and therefore a non-uniform composition. So here we can say that a mixture that has a uniform composition is called a homogeneous mixture, whereas a mixture that has a non-uniform composition is called a heterogeneous mixture. Now let me take another mixture of food color in the same quantity of water. But this time, I am going to add 5 drops of food color. Now when we compare this with the mixture of food color in water taken earlier, we notice that the color of this mixture is more intense than the previous one, even though both have uniform distribution of particles. So it is possible for mixtures with uniform distribution of particles to have variable intensity. That is, if you added 10 drops of food color to water, the mixture would still look uniform, but the intensity of color would be even higher. Also, due to the uniform composition of homogeneous mixtures, they are also called true solutions. Hey, what about the sand we were talking about earlier? What kind of mixture would you classify sand into? Well, sand has physically distinct components and is therefore a heterogeneous mixture. Now, what if I ask you to identify mixtures around us as homogeneous and heterogeneous? Let's try out some examples. What if you pour out a glass of lemon juice? You will find that every part of it has uniformly distributed particles. Also, every part of it tastes the same. Lemon juice is therefore a homogeneous mixture. But if you look at a pan with cooked food, you will find distinct layers of oil and water. This mixture of oil and water is therefore a heterogeneous mixture. Another example of a homogeneous mixture that I mostly see in my kitchen is sugar syrup. And another heterogeneous mixture I see around is egg yolk. Egg yellow and white are distinctly separate from one another. Next time you see different mixtures, try to identify them as homogeneous or heterogeneous. I'll sure that will be fun. Now that we can identify homogeneous and heterogeneous mixtures, what about milk? Is it homogeneous or heterogeneous? It looks uniform all throughout. But is it really a homogeneous mixture? We will find out soon in our upcoming videos. This brings us to the end of the session. Let us go through the recap. Mixtures can be classified into homogeneous and heterogeneous mixtures. Mixtures that have a uniform composition throughout are called homogeneous mixtures. Mixtures that have a non-uniform composition are called heterogeneous mixtures. Homogeneous mixtures are also called true solutions. We will be back with more about mixtures and their properties in our coming videos. Till then, keep learning.